Hello everyone. Welcome to my channel Chemistry by ANR. This is the unit of atoms and molecules. We need to know what are atoms, what are molecules, since we know what are matter, or rather what is matter. So matter is anything that occupies space and has mass. So matter is made up of small particles which are called atoms and molecules. Small particles which are called atoms and molecules. Now different kinds of atoms and molecules have different properties due to the different kinds of matter, due to which matter also shows different types of properties. We have seen that matter is existing in three main states like solids, liquids and gases. Now the atoms or the particles that are made, that are making the solid or making the liquid or gases, they have different property for which what is happening, the matter is exhibiting different property. Now the atoms of different types of matter, they are different, they show different property. That is, the atoms are all known as, you know what, the atoms are known as parmanu. That means the ultimate particle is known as parmanu, atom. So atoms combine to form molecules. So here let us see the laws of chemical combination, how the atoms combine, as per what rule, what law. Let us see them one by one. Laws of chemical combination actually means that when molecules or atoms are combining, what rules do they follow for that particular combination? The first one is law of conservation of mass or law of conservation of matter. This is something which we will study in physics also, not only in chemistry. That was given by Lavoisier in the year 1774, which basically means that matter is conserved, mass of the universe is conserved. Now in a chemical reaction, how can you apply it? The mass of the reactants will be equal to the mass of the product. So let us first see the law of conservation of mass. It was given by Lavoisier in the year 1774, and it states that matter is neither created nor destroyed in a chemical reaction. Or the law of conservation of mass means that in a chemical reaction, total mass of product is equal to the total mass of reactant, and there is no change in mass during a chemical reaction. That is what is happening. So if a reaction is represented like this, A plus B forming C plus D, where A and B are known as reactants. That means they are reacting, and so on, they are known as reactants. And C plus D are known as products. They are known as products. Now what does it mean? That which are reacting, they are reactants, and they are generally on the left hand side of a chemical equation. And that which are formed are known as products, and they are on the right hand side of a chemical reaction. Now whatever is present in the left hand side, the total mass on the left hand side should be equal to the total mass on the right hand side. That means the total mass of the reactant, that is mass of A plus mass of B, will be equal to mass of C plus mass of D. Now it does not mean that reactant can be two only. It does not mean that product can be two only. It can be one or many. So let us see one particular reaction over here. Calcium carbonate is being heated. So when it is heated, it is breaking down to form calcium oxide and carbon dioxide. You have to remember the names. Calcium oxide is CaO and carbon dioxide is CO2. And when you heat this particular reaction can be named as thermal decomposition reaction. This is thermal decomposition reaction. Decomposition reaction means when a particular reactant is being heated and it breaks down to two or more. It can be two or more product. So one reactant gives two or more product. That type of reaction is known as decomposition reaction. And to carry out decomposition, when you apply heat, that is known as thermal decomposition reaction. Now, it means the mass of A should be equal to the total mass of B plus C. So mass of calcium carbonate was 100 gram, and after the reaction it is seen mass of calcium oxide is 56 gram, carbon dioxide is 44 gram. When you total them, it comes out to be 100 gram. So here we can see the mass of the reactant is equal to the mass of the products formed. So this is an example of law of conservation of mass, or we can say this example supports law of conservation of mass. So this is the evidence. Now experimentally to verify, what is this experiment? Let us understand. So a conical flask is taken. This flask is conical flask. Above there is a rubber cork and this is a small test tube, and we need a thread. This is all we need. Now what are the chemicals being taken? Inside we have barium chloride solution. Inside means inside the conical flask we have barium chloride solution. Inside the test tube we have sodium sulfate solution. Now, you have to now understand what are the formulas also. Later on, you will get to know that more nicely, but maintain the habit of knowing and seeing them. Barium chloride means BaCl2. BaCl2. Sodium sulfate means Na2SO4. Okay, so these two are kept. One is kept in the conical flask, that is barium chloride, and in the small test tube sodium sulfate is kept. Now in this type of attachment, you see the thread is coming out and it is made tight with the rubber cork such that the two solutions do not mix. That is the first thing. They do not mix in the first case. In the second case, the rubber is lifted up, and for which the thread comes down and the test tube automatically gets inverted and the solution is poured into the conical. So here you have the reaction between barium sulfate and sodium chloride occurring. So here, getting formed. That means barium chloride and sodium sulfate reacts to give you barium sulfate, which is BaSO4, and sodium chloride, which is NaCl. Now here this will be 2NaCl and the reaction will be balanced. So it means the mass of BaCl2 plus Na2SO4 will be equal to the mass of BaSO4 and twice NaCl. Now how to check that? For that, in the first step, you have to take the mass of, say, the apparatus, mass of apparatus. What all apparatus you have taken? You have taken a conical flask, you have taken a small test tube, and you have to take the mass of the apparatus. Say the mass of the apparatus is X. And after you have added barium chloride and sodium sulfate, that is in this case, the first case, before the reaction, again you take the mass. So now you have to take mass of apparatus plus reactant. When you take this, maybe this is equal to Y. Y means what? Y means reactant and apparatus together. Now I can say that from this, the mass of reactant is what? The mass of reactant will be Y minus the apparatus mass. Y minus X is the mass of reactant. So this you can measure. And next what you can do, when you have added these two solutions after leaving the thread and you are getting barium sulfate and sodium chloride, now you take this apparatus, you take the total weight. Okay, you take the total weight. When you take the total weight, that means apparatus plus product. When you take this weight, say this is number 4, apparatus plus the product. I have written PDT for product. Say this is coming Z. Okay, so if I say Z, then what is the mass of the product? You subtract the mass of the apparatus from it. So you can say mass of product is equal to apparatus plus product Z minus the mass of the apparatus X. So Z minus X. If the law is valid, then you will see Y minus X is coming equal to Z minus X. This is the law. That is, mass of the reactant is equal to the mass of the product. Or I can say, since the mass of the apparatus is fixed, so I can also say that mass of the apparatus X plus mass of the reactant, that is together what it is? Together it is Y. Together it is Y. See, mass of apparatus and reactant, that is Y. And mass of apparatus and product, that is Z. So Y should be equal to Z, because the mass of the reactant should be equal to the mass of the product. I hope this concept is clear. Now, next, here we can see this reaction, what is happening. It is the reaction between barium chloride solution and sodium sulfate, giving barium sulfate and sodium chloride. So here again you can practice, write BaCl2 solution. So write AQ. AQ stands for aqueous, and what does aqueous mean? In water. In water, that is the solution in water, plus sodium sulfate, Na2SO4. Now this is also solution, aqueous, forms barium sulfate, BaSO4. Now this BaSO4 is what? BaSO4 is a solid, white solid, it's a precipitate, plus sodium chloride 2, NaCl. This is aqueous. You know what is the meaning of aqueous and what is the meaning of precipitate. Ye downward arrow. This downward arrow means precipitate. 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 Precipitate means that which is insoluble in water. That is precipitate, because here you have taken the solution in water. So this is insoluble. So it does not dissolve in the solution. It settles at the bottom. And the color is white. BaSO4 solid is white in color. So it is essential to give the downward arrow. To write it is white in color. And rest all are AQ. They are aqueous, means BaCl2, barium chloride, is soluble in water, sodium sulfate is soluble in water, and in the product 2NaCl, that is also soluble in water. So next we can see over here, in an experiment to verify the law of conservation of mass, the following data is given. See, mass of barium chloride, mass of sodium sulfate. So these two are the reactants. 1 and 2 are the reactants. So you can see mass of, so barium chloride and sodium sulfate are mass of reactant. Do a total and you will get 35.0 gram. Mass of barium sulfate as the product and mass of sodium chloride as the product. When you add them, you get mass of product, which is again coming out to be 35.0 gram. So it shows mass of reactant and mass of product, they are same. Mass of reactant and mass of product are same, and thus it verifies the law of conservation of mass. Now this is again an important question from NCERT. We can see sodium carbonate, one of the reactant, sodium carbonate reacts with ethanoic acid. This is ethanoic acid to form sodium ethanoate. That means carbon dioxide and water. So what you need to know is that sodium carbonate and ethanoic acid, they are reacting, means so they are reactant, and these are formed, so they are product. You just need the individual masses, nothing else. You don't need the formula, but then also I told you, have the habit of seeing them. Sodium carbonate, it means Na2CO3, sodium carbonate. This is aqueous. Reacting with ethanoic acid. Ethanoic acid is CH3COOH. This is 3. This is also aqueous you have taken. It forms sodium ethanoate. CH3COOH के जगह पे Na. This is also aqueous and not precipitate. Carbon dioxide, CO2 gas, and water, which is liquid. So this is the reaction. So you don't need to remember the formula, but you need to gain the habit of seeing them. So mass of reactant, reactants में क्या है, सोडियम कार्बोनेट है, तो गिवन है मास ऑफ सोडियम कार्बोनेट जो कि 5.3 है. देखो 5.3 ग्राम ऑफ सोडियम कार्बोनेट रिएक्टेड विद 6 ग्राम ऑफ इथानोइक एसिड. तो ये रहा तुम्हारा मास ऑफ रिएक्टेंट. फिर प्रोडक्ट में क्या बना, 8.2 ग्राम ऑफ सोडियम इथानोएट. सो दिस इज 8.2. 2.2 gram of carbon dioxide and 0.9 gram of water. So these all are your products. When you add them, you see that the mass of reactant and the mass of product are coming out to be same. So this verifies law of conservation of mass. The next example, calcium carbonate decomposes on heating. अभी तुमने इसको देखा, राइट? कैल्शियम कार्बोनेट इज अ सॉलिड, you know. So when you heat it, it decomposes. Decomposes means it breaks down to form calcium oxide. So what is your reactant? Calcium carbonate is your reactant. What is your product? Calcium oxide and carbon dioxide, they are your products. CaO and CO2, they are your products. Now mass of calcium carbonate is 10 gram. So mass of reactant is 10 gram. Okay, so when 10 gram of calcium carbonate is decomposed, so I am writing here 10 gram completely, then 5.6 gram, I am writing here 5.6 gram of calcium oxide. Calculate the mass of carbon dioxide. Take this to be x gram. So from, you can say, from the law of conservation of mass, we have mass of product should be equal to the mass of reactant. Now mass of reactant is 10 gram, that is mass of calcium carbonate, and mass of calcium oxide 5.6 plus mass of carbon dioxide, say x gram. So you can say 5.6 plus x is equal to 10. Therefore x will be equal to 10 minus 5.6, which is equal to 4.4 gram.